Yep. So very excited for our next talk with Matthew Cox. The talk is animating equity, Python dashboards for small town housing and displacement risk. This talk is going to demonstrate how open source Python tools like censusdis, pandas, and folium can be combined to create an interactive, time-enabled dashboard for visualizing economic vulnerability, housing affordability, and displacement risk in small communities. And as I just mentioned, Matthew is from North Carolina and is a Python hobbyist. So with that, happy to hand it over.
All right. Thanks, Jim. Morning, everybody. Thanks for showing up. We're going to talk a little bit about animating equity. Is the title of the talk. It's what we're going to do is talk about a project that I took on based on happenings in my little county in North Carolina and my small town in North Carolina. I'll give you an overview of what that looks like demographically in a few minutes, but um, basically what we'll be doing is looking at how we can use geospatial data to tie demographic data measurements from the US Census. I know that some of you are joining internationally, but the United States Census Bureau not only takes a 10-year census of demographic data for all citizens, but also produces something called the American Community Survey, which captures data for municipalities, counties, and states in between those 10-year censuses. We'll talk a little bit about what that looks like for not only my small town, but also larger towns. How it affects the validity of the data. Overall, this project came about in order for me to satisfy my curiosity. The idea that is coming around, at least in my little town, is that um, big development is on its way. And that means that in typical American fashion, a lot of large corporate developers are coming into my rural town, my rural community, and taking farmland and trying to turn that into very large housing developments. That means single family homes, and basically cutting down trees and scraping the area and putting up a lot of single family homes. And what the data shows is that might not be too healthy. While a lot of the areas are being that are being purchased and scooped up are actually outside of the bounds of the town, outside the centrum of the town, if you will. It creates a lot of pressures for vulnerable populations within the city. And we'll talk about what that looks like here in just a second. Um, I've kind of gone over a lot of this, a little bit about me. I am what you would call a citizen hobbyist, I think, Python developer. I do work in not only just Python, but also Python Django. I put together, again, to satisfy curiosity, a lot of web apps for myself and for friends and family. Um, the things that got me curious with this sort of, let's say, political happenings and economic happenings in my town was the fact that there are data sets that show us exactly what's going on if we pay attention to the data. Um, in my professional life, not just my hobby life, I do a lot of data visualization in things like Microsoft's Power BI. And I've found that if you can take data for the layperson and put it into something visual, it tells a much more powerful story. So, what I decided to do was really take the data, look at the health of my little town, and make some data driven statements about what the history has shown for us and take a look at forward looking what certain changes and certain policy decisions could do to the town, to not only the populations that are living here, but how those populations might change based on uh, basically urban planning decisions that are being made. So the thing that I want you to think about is how to make invisible patterns visible, meaning looking around neighborhoods and realizing suddenly that half of your neighbors you don't know anymore, all your elderly neighbors are gone. uh, Basically folks like single parents, people who are at risk, uh, they basically moved out over a certain amount of time, and we've seen that happen in a lot of United States cities as basically you know rural areas start to turn into um, more populated, more densely populated housing type developments. So, what I've done here is looked at things like my hometown, housing stability, and something we're going to talk about a lot, which is called displacement risk. Now, there's a word that gets bandied about in the United States a lot uh, called gentrification. And what that means is when historically uh, underprivileged areas suddenly turn over into redeveloped areas where potentially lower earners, lower median income earners are replaced by higher median income earners. We see it particularly in uh, populations of color, populations that struggle with poverty, populations that struggle with the cost of rent versus their median income. They get displaced. That means neighborhoods get quote unquote gentrified. So I wanted to see how that may start happening in my little town. And I turned to the data. What I've done is use Python to get US Census data through a library called censusdis. We'll talk about why that's a great package, at least for me as a data consumer. And we'll talk about folium and what folium does to help visualize geospatial data. So I promised friends and family who were going to be looking at this that I wouldn't carry on too much about myself, but get it more about the project. So let's take a look at the case study. The test case is my hometown, Oxford, North Carolina. I am a relatively recent addition to the town, meaning I moved here 10 years ago. It's a southern town, southern United States town with a lot of very long roots, and of course, the United States. That means families who have lived here only 300 years or so. It's historically rural. The economy here has been historically agricultural for the most part. It's got approximately 9,000 residents. It's located in Granville County, and that county is important. You'll see why as we get into the actual code. And it's roughly 30 minutes north of a city called Durham, North Carolina. If you're familiar with technology and technology companies, you know the Research Triangle of North Carolina is home to a lot of larger technology type companies. We're I guess, a bedroom community for a lot of that kind of industry. Oxford's inner neighborhoods experience a lot of negative economic indicators, and we'll talk about those indicators in a few minutes. That means higher renter shares. That a majority of the individuals in those inner neighborhoods are actually renting their homes, not owning their homes. They experience high rent burden, which what that means is at least 30% of their monthly income or more is going to pay for their housing, for their rent. There's concentrated poverty. That means that certain neighborhoods, at least in the inner part of town, experience high rates of poverty, at least according to the US Census. They experience a large SNAP participation. SNAP is federal food assistance. So those families that are living in those neighborhoods, large portions of them, sometimes more than a quarter of them, are receiving federal assistance from the United States government in order to pay for food on a monthly basis. Um, a lot of them are majority African American census block groups. And of course, there are other communities of color located within those particular census block groups. And there's an aging housing stock, meaning the houses have been there in some cases, 100 years, and were put there primarily to feed industries that no longer exist in the town. Um, Here's the challenge that we've got, the out of town challenge. And I say, but not for long, because the city is expanding. The boundaries of the town are surrounded primarily by farmland and unincorporated areas. That means areas that live outside of the governed area of the city. Um, uh, as I mentioned before, a lot of developers have come in and sought what's called non-contiguous annexation. That means not building at the edge of town, but maybe building a mile outside of the town limits, but asking the town for services. That could be water, that could be sewer, stormwater, police, fire, safety. It's a practice that was widespread in the mid to late 20th century in the United States. The problem is the practice is also almost always led to economic challenges for the cities that engaged in that practice. Um, the subdivisions themselves are for sale. That means that the subdivisions being created or being proposed are outside of the city limits for purchase. They're mid to upper income homes. They're not rental homes. And this is important because they're not the type of homes that are going to feed existing populations who are under the conditions where they're renting homes rather than purchasing them. Um, but here's the policy conflict, and here's what I wanted to test and challenge the notion that all of this sort of development is a net positive. Um, for governmental entities, the for sale units will expand the tax base. They will actually make money on an annual basis from these out of area expansions, but they don't tend to stabilize rental markets in the core city. In fact, they do a couple of things. They destabilize them by increasing property values, which in turn increases tax rates on rental properties, which tends to create increased rents and basically create areas where uh, rental properties may be converted into for sale properties as existing property owners look to get out of those rental properties to make good on any gains they may have had in property values. Um, I've already mentioned that land and tax value changes spill inward, meaning even though those locations may not be the new locations may not be associated with the inner town neighborhoods, they are going to have an economic impact, whether you know it or not. So here's why Oxford works as a test, as kind of my white paper. It's small enough to require some really careful data handling. That means that basically you can see the effects of the data as we progress through and look at the data and visualize it. But it's complex enough to take a look at the housing and displacement dynamics that are associated with the census data. It's also growing fast enough so you can see policy changes and policy stakes change year over year. And we'll look at a couple of census blocks that make pretty drastic shifts associated with development changes and housing inventory changes. And then we're going to take a look at the open data sets in a moment, but Oxford is still supported by these open data sets that are available from the US government. And we'll talk about how we can modularize the actual API pools that we use to grab that data and generalize it to other US small towns. And I'll talk about how you can modularize that, especially if you want to take a look at it in your area of the United States. So we talked about the displacement risk data and the displacement risk model. Basically, the reason why we look at the model is that I've likened it to boiling a frog. As these housing pressures happen, they can happen in such a way that they're not necessarily very clear in everyday practice and everyday observation. It's a slow burn for a lot of this, and when the analogy is sometimes you can boil a frog so slowly that if you do it slow enough, the frog never knows that it's being boiled. And the idea is that these housing pressures, these market dynamics, can basically uh, happen very quickly over time, but in a very quiet way. And the displacement risk model looks to track it over time. I've got the data from 2017 to 2023. I was hoping by this talk that I would have the 2024 data, but it looks like certain U.S. government shutdowns over the past couple of months have delayed that until January of 2026. So it's allowing us, though, to convert that data into an actionable policy decision. It helps us to look at how the growth that's happening slowly over time is impacting the decisions that we can make in the future. And it also looks at, uh, very importantly, housing affordability, which is a topic in urban planning right now, and I think in governments, local governments, national governments across the United States. One of the biggest topics is housing affordability, especially for what we consider workforce, whether that's blue collar workforce, and also for first time home buyers. So, the whole idea of the displacement risk model is, as you see on the right hand side, to create actionable local policy. It means that if you've got the right data, you can look to make very informed, very equitable housing decisions. And we'll talk a little bit of the social justice implications that come with the displacement risk model. Let's talk about the data sources, and this has been key to me, primarily as a hobbyist. I'm worried about if I ever talk to somebody about this, if I ever presented it, and I have published these maps so that everybody can take a look at that worldwide on GitHub, and we'll show that in a second. Um, I wanted to make sure that the data itself was uh, pretty standardized. It needed to be publicly available for people to go out there and see. It needed to be free, and personally, it needed to be pretty dense. So the U.S. Census has been going on for what, almost 200 years now. Um, while the ACS data doesn't go back that far, going back almost a decade to watch changes happen in small municipalities is very valuable. So I gather that data from the US Census using the censusdis Python package. And the beauty of censusdis, which we'll dive into in just a second, is that it wraps everything into a really nice API call. There's not a whole lot of going out with requests or downloading local files to get the information. You can make quick refreshes from it just by making an API call and bring it down with some very minimal code, which we'll look at in a moment. We'll talk a little bit about the shape files that I need to get sometimes for mapping. There's only one shape file that I need to grab typically, or that anyone would need to grab if they're going to modularize it for their area. That's available from data.gov, which is a government website run by the U.S. federal government, which gives you GIS data for a variety of locations throughout the United States. One of the things that we talk about also is food availability. Believe it or not, there are what we call food deserts in certain small towns in the United States, and um, food access is important in this model. And the U.S. Department of Agriculture actually tracks food access for certain census block groups throughout the United States. Um, as I said before, because this is open source data, anybody who uses this package or uses this project's code can see how the indicators are built. Um, it's not cooked, it is pretty much raw, fresh from the United States government. So, as you pull Census DIS API pulls, you can see that it really refreshes data based on availability. So you don't have to do a whole lot of data manipulation up front. You can see that I do some calculations based on the type of data that we get from the census. But really, I want this all to be sort of evidence based rather than opinion. That was the main thing that I wanted to have. So um, connecting data is important when you're mapping, because while you can look at any number of maps, the important thing about this is the fact that you have a connection between what's called geometries and the area related data. Geometry is coming from a shape file, and the shape file, you can consider it like, it's really just a spreadsheet. It's tabular, and it stores basically information just like anything else: population, income, poverty rate. There's so many things you can pull from the U.S. Census, but it also stores geometry, and geometry is essentially a list of Cartesian coordinates that are going to do, well, three things. It can get you points, a single location decided by latitude and longitude. It can bring about a line like a path or a street, or a polygon. And polygons are useful because we're talking about neighborhoods. We're talking about um, basically a census block group is a neighborhood organized by the census so it can track changes over time. Um, the shape files allow you to tie the data to those geometries so that as I, and you'll see it in a moment, as I track changes over certain block groups, I want to know what the polygons are that are related to the data associated with that. And that's what the shapefile does for us. We talked about censusdis. Censusdis basically helps you grab the data, load it. It according to censusdis GitHub, you can see there it pulls a majority, if not all, of the U.S. Census demographic data that's available through the U.S. government's API. It allows you to grab geographies. That's what's very important. Um, you can set geographies to any number of granular levels, all the way from the census tract, which is probably more of almost an entire municipality, down to block groups, something I personally am using because of the neighborhood level of it. And it helps you track, all kinds of mapping capabilities and data support. The user experience is fantastic. Um, Without Census DIS, you're calling a Census API with any number of Python tools. The request package, I'm sure a lot of you have used that before. You're cleaning up the data manually in CSVs or in pandas in the console. You're matching it to hopefully to shape files that you've downloaded locally. You're trying to make sure that GeoIDs, something that's pretty the ubiquitous identifier for census tracts themselves, and trying to match that up. With Census DIS, you've pretty much got 3 lines of code in order to download any year. Census DIS calls it a vintage, any year's worth of information. Something else, I was talking to a friend of mine about how this was all working, and they said, "GeoPandas, what's that?" Well, GeoPandas is, if you've used pandas, if you worked in any tabular data, GeoPandas is a data frame which has a special column for geometry. So GeoPandas is a great way to grab points, lines, polygons, multiple polygons. Say if you wanted to have areas throughout a city. And tie it back to data just like you would have in a normal pandas data frame. So let's talk about the workflow. As right before we get into the code here, I am going to try to share some code in a notebook. Um, the workflow goes this way: you're grabbing the raw Python data with the Census DIS API pull. I do some data manipulation in order to create essentially human readable values for the data frame as I look to visualize it. I calculate displacement risk. Remember, this is all about knowing whether or not your neighbors are going to be there in 2 years after all the development happens around you, and visualize it on a map. And what I've done to animate it, we'll see in a second, is basically create timestamps and do some visualization so that you can play the changes in the maps over time. And then we take all of that, we put it into using folium, create an HTML output. So you basically just load an HTML file into your browser, and you can interact with the entire map using Leaflet, which is a fantastic mapping package that we'll talk about in a moment. All right, let's look at some code. I am going to head over here real quick and my notebook. As you can see here, I've basically taken the code itself and dropped it into a notebook so that we can kind of follow along. This notebook will be available on the GitHub repo that I'll share here at the end of the talk. The first things first, we're going to do all of our imports. You can see here that we've got things just basics. The keys here are folium and some elements within folium. I'm using a color map from Bronca. Basically, this allows you to set certain colors for certain values within your folium map. Um, and then I've got a couple of constants and a couple of functions that I've got outside of the main script. First thing we're going to do, and this is the only manual data load that we have to deal with, is pull all the information over from files that I've downloaded from USDA. This is a pretty common, this is a pretty easily accessible file in the GitHub repo. You can see I've put the sources out there so you can grab it. Also, I'll share the slides later. They have direct links to download these. I grab the CSV, grab it as into a data frame. I grab the shape file from the that gives me the block groups for that relates back to my USDA data. I have basically filter it so that it's not a uh, huge file. I filter it on my county. I basically make some renames happen and give myself a Boolean value of whether or not any particular tract is a food desert. And in the case of food deserts in my area, that means that a grocery store or a place to buy food is between 1 and 10 miles away from the majority of the population living in that tract. Then I am going to, here's where the magic sort of happens. This is the pull for my main census data. I'm going to go and grab all of that census data here. We'll execute that. What I do is I grab for each vintage, and here's my constants. We'll have to go back to constants. The years I basically have selected here 2020, 21, 22, and 23 to make sure this moves quickly. Um, I can grab anything as far back as I want to, or looking forward. I run that, and basically using this function that allows me to tailor the data how I'd like it. I know we're coming up probably a little short on time, but the data set itself, ACS5, that's for cities under 10,000 people. The vintage itself is in the constants. I have block group variables, which I'll show you in just a moment. Those are the actual variables for each demographic column within the data set that I'm trying to grab. The state is North Carolina, obviously. My county, I'm pulling all block groups for the county. And this is really key, geometry equals true. So I've pulled all that. I've used these block group variables. As it comes in, I'm going to do a whole lot of renaming of these variables, creating population shares, median rent. We can roll through these. And you can kind of see that as all of this comes in, we clean and sort the data. It should take about 1 second. But here's where it's really important. The scaler itself, I'm going to
So,
scale everything.
sorry to interrupt, but we do
Sorry.
have to be on time at 10 a.m. because the
Oh,
next meeting
sorry,
can't
Carrie.
start. But
Thanks.
thank you so much, Matthew. If
Okay.
anyone has any questions, just run over to Discord. The
Yep.
link is in our resources. We appreciate it.
All right. Thanks,
And
all.
yeah, everyone have a
Okay.
good day.
Thank you.
Thank
All right.
you.
Bye now.